Hi, and welcome to the section Designing Spring Applications Using Microservices, which is the section 3 of this course. In this section, you will learn about how Spring uses microservices for distributed systems and current business requirements. In the first video of this section, you will explore microservices mainly and what Spring 5 provides to its developers. In the second video, you are going to have a better understanding of microservices architecture. In the third video, you will look into microservices types and their architectural requirements. In the last video of this section, you will learn how to use microservices to resolve business issues in distributed systems. The title of this video is Exploring Microservices in Spring. In this video, you will have an introduction of microservices first. Then you will look into its advantages over monolithic applications while using for current business requirements. Then you will look into its architectural features. Also, we will discuss challenges that are faced by developers while building microservices that are scalable and manageable. Lastly, you will see what Spring provides when a developer is willing to implement microservices architecture. The microservice architectural style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanism such as HTTP resource API. In simple words, microservices are a set of small, independent, composable services, each one of which can be accessed with RESTful APIs. This architectural style deconstructs business processes to their most basic level by creating small separate processes that then replace large single applications. Breaking a system into smaller parts allow each microservice to focus on a single business capability. Microservices, however, cannot live alone. They are a part of larger system. They work alongside other microservices to accomplish the task normally handled by one large standalone monolithic application. Now we will discuss advantages of using microservices instead of monolithic applications. Microservices makes application easier to develop and maintain. You can put smaller teams on the individual tasks. How else microservices help? Let's find out. First of all, it enables independent releases. There are different components running the whole system and different development teams working on different parts of system. In a monolithic system, you cannot deploy a component separately. With container technology and microservices approach to architecture, you can have independent releases and deployment of components. Each service of the component can evolve as fast as the market requires and can be tested and deployed quickly too. Secondly, microservices architecture implementation decreases development cost. You remove the business logic and data logic from your application and replace it with a set of modules of code that are built and deployed as independent entities and are reusable. You complement this microservices architecture with user interface, which is converted into modular purpose-built components. This service-based approach to application architecture ensures there is one copy of application logic for a capability, regardless of the number of applications leveraging that logic. Over time, this approach decreases development cost and you are agile, you reach your customers faster. With microservices architecture, each service can be scaled independently. You are free to choose the hardware that best matches a service's resource requirement. You can deploy an in-memory database, and you can also use CPU-intensive image processing service for database purpose. So this is easy to scale. You can use any kind of hardware. The next is fault isolation. Even if one service of the application does not work, the system still continues to function. This is called fault isolation. And next, microservices give you the freedom to choose the best operating system, languages, runtimes, libraries for the best job. In microservices architecture pattern, each service has its own database schema. This enables loose coupling. Each service can use a database that is best suited to its needs. Now let's discuss microservices architectural features. Microservices have a number of useful features that fulfill current business requirements. First one is business capabilities. Microservices are very simple and each microservice focus on a single capability. Multiple microservices together can handle multiple business capabilities. Decentralized governance. Deployment of microservices focus on using only the right tool for the right job. They have the freedom to choose the best tool to solve their problem. Continuous delivery. It allows frequent releases of software through systematic automation of software creation, testing, and approval. Componentization. Microservices are treated as independent components that can easily be replaced and upgraded. Agility. Microservices support agile development at any new feature can be quickly developed and removed too. Autonomy. Teams can work independently while building microservices, which leads to increasing development speed. Decoupling. Services within a system are largely coupled, so the application as a whole can be easily built, altered, and scaled. Responsibility. Microservices do not focus on applications as projects. Instead they treat applications as products for which they are responsible. Now we will discuss challenges of building microservices architecture. The features we discussed in the previous slides don't come for free. There are some of the challenges of building microservices that are scalable and manageable. Data consistency and integrity. A basic principle of microservice is that each service manages its own data. This keeps services decoupled but can lead to challenges with data integrity or redundancy. Service boundaries. When you build microservices, you need to think carefully about where to draw the boundaries between services. Once services are built and deployed in production, it can be hard to refactor across those boundaries. Continuous integration and continuous delivery. One of the main goals of microservices is agility. To achieve this, you must have automated and robust continuous integration and continuous delivery so that you can quickly and reliably deploy individual services into test and production environments. Complexity. Microservices application has more moving parts. Each service may be simple, but the services have to work together as a whole. A single user operation may involve multiple services. Network congestion and latency. The use of many small granular services can result in more inter-service communication and longer end-to-end latency. So as a solution for this, good API design is important so that the services remain loosely coupled and can be independently deployed and updated. Monitoring. Monitoring a distributed application can be a lot harder than a monolithic application because you must correlate telemetry from multiple services during their communication. Communication between clients and the application. When you decompose an application into many small services, how should client communicate with those services? Should a client call each individual service directly or route requests through an API gateway? So that's the challenge while building microservices. Now we will discuss the solutions for all of the discussed challenges while building microservices. Spring provides solutions for challenges with microservices architecture using Spring Boot and Spring Cloud. Spring Boot enables building production-ready applications quickly. It provides non-functional features, embedded servers, metrics which solve monitoring challenges, health checks, externalized configuration, etc. Spring Cloud provides solutions to cloud, enables your microservices. It leverages and builds on top of some of the cloud solutions open source by Netflix. The next is reactive microservices. The Spring framework uses Reactor internally for its own reactive support, so we can develop interactive microservices using Spring reactive streams. We will discuss reactive in detail in our next video.